the fundamental theorem of algebra says if the polynomial f of x has degree n greater than or equal to 1, then there is at least 1 0. Now, this version, this is not my favorite version of this particular definite theorem, but what it means in terms of application is the total number of zeros is equal to n, including all unique zeros and counting all occurrences of repeated zeros. So, for example, look at this polynomial, right? Because x plus 2, and x plus 2 occurs that many times, I could actually get the answer of x minus 2, and x minus 2 from all those. Those are my zeros. So those are 3 repeated zeros. Then I have x is minus 5, and x is plus 5, x is minus 7 as zeros. Now, you might ask yourself, what's the degree of this? Well, the degree of this polynomial is just like we did when we found it in behavior, right? The first term, x plus 2 cubed gives me x cubed. X minus 5 gives you an x. This gives you x. So this is a 5th degree polynomial. Do I have 5 zeros? 1, 2, 3, 4, 5. So we might actually, what this means to me here in terms of graphing, I will have at most n unique x-intercepts. So in this case, if a 5th degree polynomial could have 5 x-intercepts, this one just has actually 1, 2, and 3. So a polynomial has at most n unique x-intercepts. And related to that, and at most n minus 1 turning points. No, it does bother me. Anyway, it bothers me that I've done red, but too late now. Again, turning points are a peak and valleys of our curve, or relative maximum and relative minimum if you want to be all mathy. So if you want to look at this idea of x-intercepts and n-1 turning points, what I mean is, here's a picture. I have 1, 2, 3, 4 x-intercepts. Because I have 4 x-intercepts, if you look at this, between every x-intercept I have to turn around, right? So 1 turning point, 2 turning points, 3 turning points. So I can only have at most n-1. So in this case would be n-1, or 4-1 gives you 3. Can I have, again, it says at most, so I can have less than 3 possible intercepts. Again, actually, this shouldn't be there. Unique shouldn't be there. Because if it's repeated, right? If you look at this right here, if you look at this one right here, right? This right here, it only has 3 zeros that are unique, but it has 5 degrees. So this one here could have 4 x-intercepts. I'm sorry, at most 5 x-intercepts, and at most 4 turning points. Now it doesn't have that many because x equals minus 2 is repeated 3 times. So it only has 3 x-intercepts, which means it has at most 2. But we'll see how that works. Okay. One other thing to kind of talk about before we get to a big sketch is multiplicity. Of zeros. If a polynomial has a factor x minus c that occurs k times, we say the zero x equals z has a multiplicity of k. Right, this right here, this x minus c equals k times, all we're saying is, all that really says is, you have x minus c to k power. That's all that says. If you want to reduce that down. So, let's find an example here. Find the zeros and state the multiplicity. So, given these are all linear factors, right? We should be able to look at and tell the zeros, right? So x squared is a linear factor, which means x equals 0. X minus 5 is a linear factor, so x has to be 5 is your 0. And then finally, x plus 4, also a linear factor, equals x minus 4. And all we got to do to find multiplicity is look at the degree of the factor, right? So x equals 0 has a degree of, or x squared, so x has a degree of 2, occurs 2 times, so this is multiplicity. Two. We'll call this m is degree 1, so 1. And over here, m is degree 3. So multiplicity, it just tells you how many times that 0 is repeated. And your multiplicity should add up to n. So just note here. The total of multiplicity of a polynomial adds to the, sums to the degree n of the polynomial, right? So we look at ours right here, x squared, x cubed. This is x to the 6th. Well, 2 plus 1 plus 3 equals 6. Now, the reason we care about multiplicity is it actually determines behavior of the curve. And it does two types of behavior. It tells you how the curve behaves at the x-intercept, and also tells you a little bit how it behaves near the x-intercept. So first thing, a 0 of even multiplicity will touch the x-axis and turn away. So that means, picture-wise, it'll come down, hit this, and just bounce off. So it's still x-intercept, but it's not going to go through. A 0 of odd multiplicity will pass through the x-axis. So something like that, or like that. Well, all these zeros on that picture have an odd multiplicity. And the last thing is, so the higher, so actually I should say this. For multiplicity, of 2 or higher, the curve flattens out near the 0. All right, here we have example using 3 evens, right? So as the multiplicity of 0 occurs, if we look at this, what are the zeros here? At x, y equals x squared, x is 0 with m 2. X is 0 for y to the 4th, m equals 4. X equals 0 for x is 6, m equals 6. And you look right here, right? Look near this around the 0, it gets flatter and flatter near that 0. Again, this is just an example using evens. Odds behave the same way. At the 0 for x cubed, x to the 4th is lower. So, right, x cubed is something like this, and then we'll have, well, that didn't work. We'll get flatter. So it doesn't matter whether it's an odd multiplicity or an even multiplicity. In this case, it will get flatter the higher the multiplicity. All right. So here we are. Let's sketch something and see how it goes. All right. Now it's time to sketch a graph, put this all together. So we're looking at in behavior. Zeros, and we'll go ahead and look at the y-intercept. So for in behavior, we need the term. So we're going to have minus 3x squared. We're going to take all that. The x plus 2 squared gives you an x squared. And the x minus 5 gives you a cube. No, I'm sorry. The x minus 5 cube gives you an x cubed. So our lead term is minus 3x to the 7th, which degree, or n equals 7. That means you're going opposite directions. And our lead coefficient minus 3 is less than 0. So again, a positive lead coefficient means positive x's here, positive x's here make positive y's, and negative x's make negative y's. If it's negative lead coefficient, which is what we have, that means positive x's make a negative y, negative x's make a positive y. So we want this case here. We're going to go up to the left and down to the right. And then we're going to talk zeros. Zeros mean f of x is equal to 0. Since these are all linear factors, we just pull them off. X squared gives you x equals 0. Since it's x squared, that means x squared 2 times. The multiplicity is 2. X plus 2 means x is minus 2, multiplicity 2, because that factor occurs twice. And then x equals 5 with the multiplicity of 3. We'll note here, these are even multiplicities, so we're going to touch and turn. While this one here will go through. We will also flatten here. Add a x equals 5 a little bit. And finally, things got out of the way. The y-intercept. Y-intercept will always occur when x equals to 0. So f of 0 will be minus 3 times 0 plus 2 squared. X 0 minus 5 cubed, which will just be 0. So we're going to cross the y-axis at 0, 0. I believe that's it. Now we're going to draw a picture. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we're just going to kind of note here our in behavior. Our in behavior says up to the left and down towards the right. So we don't forget it. Dropping our x-intercepts, we got 0, minus 2, and 5. So we're going up and left, which means from the side over here, we're going to go down toward my first 0. So we'll come down to minus 2. Now note, at minus 2, we have multiplicity of 2, so it's going to hit that and turn around. Come down, going to hit that, bounce up. Now I have to turn around somewhere between minus 2 and 0, so I can come back and hit the x-intercept of 0. So turning around, hit that. At 0, I have multiplicity of 2, so we're going to bounce back up. And now I have to turn around and go through at minus 5, plus 5 because it has an odd multiplicity. We're going to flatten out a little bit, so we'll come through here, flatten down, and keep going. And that's something of what our sketch will look like. All right, that's it. My name is Brian Southworth. Thank you for watching this video. Let me know if there are questions.